John, Profibus is widely recognized as the worldwide leading Fieldbus system. Can you explain to us the fundamentals of the Fieldbus technology?
Fieldbuses evolved in the late 1970s, but to understand the Fieldbus technology itself, we need to understand the industry. Roughly spoken, the automation industry is divided into two categories. We've got process automation, which then belongs in those industries where we make things from raw products like mines, oil and gas, sewage treatment. And you've got factory automation, which is really the sequential putting together of things like car assembly plants, bottling machines, and so on. So automation, Fieldbus started roughly in factory automation, because that's where they needed fast response times from digital devices like proximity switches, relays, anything that would control that manufacturing process, including robotics. And out of that we got a number of very basic Fieldbus technologies, commonly known as things like DeviceNet, ASI bus, actuator sensor interface, and a couple of others. They were very, very simple because they only had to have on or off, open or closed as information. The benefits of the Fieldbus started to be recognized also then in the process automation side, where there was a much stronger demand on how to actually get this data out, because there the binary on-off technology wasn't required. What we wanted to know is a percentage of how full, how empty, how fast, how slow was the process going. And therefore the Fieldbus technology that developed into the process side was a lot more complex, and it needed a lot more research. One of the founders of that technology was then Profibus. So to get back to what is a Fieldbus, it's actually, in an ideal world, it's an open, digital, two-way, bidirectional communication network, a bit like a local area network in an office environment, a LAN. And the purpose of that is then to connect together all intelligent devices, measuring devices, valves, and so on, as well as the control environment, PLCs, SCADA packages, and any other aspects of it. The trick, though, is that there's no one Fieldbus that satisfies all the requirements. And that has been because at the one end we had the binary digital simple buses, then we got the process more complex buses, and those buses need to have some really specific requirements which are not satisfied by other kinds of buses that you hear about in the market, like Ethernet. Ethernet in the office is a very standard Fieldbus, but it could not really function today in those harsh environments for two reasons. One is that in the continuous process measurement, 80% of all devices historically are what we call loop powered. That means that the power and the signal are all on one cable. And it makes no sense to then make it more complicated and make it a 4-wire system when you already have 2 wires. So it means that a true Fieldbus for continuous measurement has to be able to have power and data on the same 2 cables. And that, of course, was really quite a special evolution of the simple bus. The second big requirement of a true Fieldbus is it has to be able to go into hazardous areas. That means it has to be EX approved, and that has a whole lot of requirements as well.
Yeah.
So Profibus then evolved, being able to, I guess, satisfy that demand. The beauty about the Profibus family is not only does it have a Fieldbus that can handle the digital side of it, or at least interface into digital, it can also handle the continuous part by having then the data and the power on same 2 cables, but there's also a higher level of Profibus which allows us to access into Ethernet and even beyond into the World Wide Web. So the Fieldbus definition is a little bit loose, but really the whole purpose is to have a bidirectional, that means data going both ways, to every single device connected to these series of buses, and can be interrogated at a higher level from a control room or even from remotely in terms of troubleshooting and so on. So that roughly is what a Fieldbus definition today sits as. The bus itself is developing, And I believe down the line we'll see the next iteration of Fieldbus. But as it is today, it is really the ability to communicate in both directions digitally with smart devices, all kinds of smart devices.
That explanation of Fieldbus technology is quite clear. How do end users and other stakeholders benefit?
Raphael, that's a really interesting question, and I'm not convinced that we have actually seen all the benefits being uncovered yet. But the fundamental benefits that people are getting today is firstly from the fact that we have this two-way communication network. That means that data can be sent to devices of any shape and size, and also from the devices. So let's take the first one. Sending data to the device would typically be done at commissioning time. That means if you want to set the range, if you want to set any of the parameters of a device, typically things like hysteresis, damping, and any other aspect, linearization, which means turning levels into volumes and so on, that you do by sending data from the control room down to the instruments, and means you don't have to go to the instruments as we did in the past for the last 40 years, where a technician has had to go down to each and every instrument with a walkie-talkie and a screwdriver and a milliamp meter, and he would then adjust the instrument, talking on the one hand to the control room to say, can you see what I'm doing? Is it been adjusted? Does it fit? Is it scaled correctly? And so on and so forth. Today you don't need to do that. You send the data down to the device. Nobody has to go into the field and go and check it.
Yeah.
So it really does optimize the whole process of commissioning plants. Second aspect of that is that the data that you've set an instrument up with is stored in a software file on the main control system. And since a lot of devices have the same setup, all you do is download once again and again with a new tag number. You don't have to reinvent the wheel every instrument you set up. So we estimate that commissioning time is cut by over 50%. And certainly in terms of costs, it's a huge cost saving because you don't need to have technicians in the field, in the heat, and so on. The second aspect is communication from the field back to the control system. And that is the part that's probably getting more exciting. The instruments, all instruments today are smart. We've got to understand that. They all have microprocessors in them, and they can do a lot of fancy stuff, including send back information. So my favorite analogy, because I'm a bit of a petrol head, is motor cars. And today, when you get into a modern motor car, you can see it doing self-check. It checks everything. It checks to see that the doors are locked, your safety belts are in, I guess that the engine oil is relatively fresh, and you on your dashboard you can tell immediately what things need attention or don't need attention. Instruments are exactly the same. Even the most fundamental instrument has a whole pile of internal checks that are going on every 30 or 40 seconds, that they check, for instance, that the membranes in a pressure transmitter are in one piece. In flow meters, they check to see that the coil current is at a certain level. They check to see that the printed circuit boards are working, that the temperature compensation is all working. There are hundreds and hundreds of checks that are taking place. The beauty about that now is that the moment that data is sent back to the control system, we can then monitor which bit of that data tells us that this device has a problem. It might be out of specification, it might need to be recalibrated, it might have broken. The industries we work in are very robust, and things do get damaged. And that's the biggest problem we've got on any kind of automation, whether it's a car assembly plant. What you don't want is for the assembly to stop because something is broken, is that we can now do predictive maintenance. The instrument will tell you that I've got a problem coming in 2 or 3 weeks, and you need to then schedule a technician to come and sort that out in 2 or 3 weeks' time. The data can also be, and this is something very new, can be integrated directly into some of the plant maintenance software tools that now exist in the bigger plants. So in SAP, for instance, they have what they call a PM module, and that does then the scheduling of technicians' time. And we can take data from every single instrument on the plant and feed that into the PM module, and it will then know exactly what to schedule, who to schedule, what spare parts are needed. Before we even start the week, we can actually program what has to happen. So that also then leads to a new aspect, which is plant asset management, which is the ability then to track the costs of ownership of each and every device. And of course that is bringing to the fore a whole lot of new things. People are saying, I've got measurements that I don't need, which are costing me a lot of money to make, and I've got measurements elsewhere in the plant that are absolutely critical that I haven't got in place. And so we can actually now start to optimize the measurements of the plants based on the running costs and the maintenance costs of all these devices. The next phase after that is really going to be the ability, and I guess it exists already, is to take that data even to a higher level. So once it's into an Ethernet environment, of course with the necessary security and permissions, you can then access that data from anywhere in the world. And that, of course, opens up a whole new avenue for things like inventory control. There are a lot of manufacturers of raw products, liquid yeast, for instance, components for making adhesives, chemicals, even ready-mix cement, where the owners of these plants sit somewhere in a boardroom in London or New York, and they've got these plants scattered worldwide. From that boardroom, you could actually interrogate in a couple of seconds exactly what inventory you've got at what site and what the total value of your inventory is. For instance, how much hydrochloric acid have I got worldwide in all the tanks that are sitting at my customers, ready to make glue or adhesives or whatever.
Absolutely.
We are only starting to unravel and uncover the benefits that come from this technology, but already all new capital expenditure on all new projects definitely run field buses, and we are still now finding out what next we can benefit from. But obviously it's been a quantum leap from the old days of the old 4 to 20 to come now to digital communication in terms of safety, in terms of efficiency, and in terms of cost of ownership.